Welcome to Everpure Technologies. The first type of filtration technology we're going to discuss is our pre-coat technology featuring the MicroPure 2 media. Pre-coat is a proprietary and proven filter technology that's found in over 4 million filters worldwide. And it features 4 times the surface area for filtration than a standard carbon block, giving it better dirt holding capabilities and particulate reduction capabilities than a standard carbon block. They come as tight as 1/2 micron filters, and they also include Aegon antimicrobial protection, which helps prevent biofilm from growing on the filter and following it prematurely, and helping prevent biofilm growth downstream past the filter. How a pre-coat filter works? Well, the water enters down through the narrow center stem of the cartridge down to the bottom of the filter can, where the water stirs up the powdered MicroPure 2 media that then coats the septum, or that folded pleated fabric, inside the can, and the water flow evenly deposits that material across this media. If that process isn't done well at startup, you can leave that fabric material naked of a filter bed, and then that material becomes the sole filtration barrier, which will fall fairly quickly. So the water then is forced through the filter bed of MicroPure 2 pure carbon media, and then through a 1/2 micron membrane, and then out through a center collection tube located just behind the stem here, and then out to the application. So providing a very, very balanced filter between dirt load and chemical extraction. MicroPure 2 with antibacteriostatic is a premium quality carbon that, with the addition of Aegon, that inhibits microbacterial growth inside a filter, because activated carbon removes chlorine from that environment, so there is no chlorine to maintain sanitization. So this helps preserve that environment, prevent things from growing. Very good and effective at killing the 1s and 2s of bacteria coming in and preventing them from growing into a biofilm bacterial coat over the filter media, plugging it prematurely. It's rated harmless to humans. It's NSF certified, FDA and EPA approved at the levels at which it delivers silver. Quick change filtration. The pre-coat filters come in a whole slew of options, from size 2 up to XC size cans, everything from base carbon filtration up to scale protection for ice makers and coffee brewers, with even specialized lead removal resins for applications where there may be lead in the water. Very, very effective filtration product. Now, Fiberdyne carbon block. This is a really neat sort of type of carbon block compared to a standard one. A standard conventional carbon block is extruded very much like a Play-Doh press extrudes a tube of Play-Doh. Well, we're doing the same thing with activated carbon here. We're holding it together with binders that are extruded under high temperature and pressure. So as we push that carbon, we're cooking those binders together and holding that block together. That creates a very dense tube of carbon that has excellent taste and odor removal characteristics. But that process leaves that filter with the effective surface area as just the outside of that filter, where dirt will only build up on this surface. So once the surface is filled with dirt, these filters plug, and that full bed of carbon isn't necessarily always used for chemical extraction. So what's different about Fiberdyne that makes it better than a traditional carbon block is simply because Fiberdyne is a slurry of fibers that are mixed with carbon and then vacuum molded around a center core. And this traps that carbon in with those fibers and in and out of them. And what this does for a fiber dyeing carbon block, it goes from being, in a traditional sense, a surface filter to a depth filter. With all this tangled fibers and webs and nooks and crannies of the cellulose fiber, it creates many, many different pathways for the water to go through, allowing dirt to work its way into the filter and then being finally stopped if they're small enough by the core. And this creates so many different pathways for the water to flow through that it's able to hold a ton of dirt but still have channels for that water to go through, keeping up flow rate. Very long-lived filter, very excellent contact time with the carbon for taste and odor and chlorine reduction. So very, very cool product that takes a problematic carbon block with surface characteristics and presents a carbon block with depth filtration characteristics that create a great dirt-holding cartridge with great chemical extraction ability. They come in a whole slew of sizes as well, from 2 up to XC, and various versions with available with phosphate for scale control, lead removal powder, and we even make a special carbonless filter with phosphate for ice applications to meet specific health standards that help prevent biofilm and slime growing inside of ice machines. Traditional carbon block, well, they're a radial flow design, which means the water enters it from the outside and goes through the center core. Well, the surface area that's available for filtration is just that outside surface area. They're commonly in 5 micron due to this surface area filtration feature. Sub-micron are available, but I would be concerned about specifying those in areas with heavier dirt loads. Very, very dense carbon and polymer resins that hold it together. The dense carbon creates excellent chemical extraction through the bed, also removes chemicals like TOC, so you get very good taste and odor control with traditional carbon blocks. They come in a whole slew of varieties as well, from 2 size up to XC can offerings. The most 2 common are the 4CB5 and the 7CB5 filters. Now, we also offer pretreatment in many ways, and mainly from the notion of pre-filtration. Basically, filters that will handle the turbidity and dirt load and protect the more expensive carbon filters behind it. When you can replace an EC210 for $13 to $15 retail versus having to replace 1 or more of the 7FCs at over $100 a piece, it's very cost effective to have a filter like the EC210 removing that dirt load before it can get to the carbon filters and follow them. And then there's the TKO pre-treatment system, very similar to this style filter, as we're putting it in front of something to collect the turbidity as it's flowing downstream and protecting filters downstream. The difference is this is a pleated surface filter, but it has a tremendous surface area. Just like the pre-coat filter is folded like a map, so are these filters. And this creates a tremendous surface area and tremendous dirt holding capability. This filter is actually 0.65 micron, so it's going to trap pretty much everything greater than 0.65 in it before it gets to the carbon filters. This offers very good protection in high turbidity areas or areas that have a lot of flocculant in it. This filter will help trap that. Whereas EC210 is 10 micron, it's going to trap all the really big particulate in the water, letting everything smaller than 10 microns through. So pre-treatment, pleated filters versus depth filters. Well, pleated filters are a fabric, so they don't have much of a bed to them. And what they do is they're simply a barrier a strainer in which the dirt collects on the outside of the fabric and doesn't really migrate into the fabric, allowing the water through. Whereas a EC210 is a depth filter where the particulate will actually enter into the body of the filter itself and load with dirt from the core out in some cases. So two different styles of filters, two different functions, two different micron classes. The nice thing is we offer filters that will fit in these housings in many micron ratings to balance what you need to remove from the water versus expense. Now, the other technology that's common in a lot of Everpure filters is phosphate for scale control, or scale inhibition as it's called. And what phosphate does is it sequesters mineral content to keep that mineral content in solution. And when we remove enough water to cause precipitation of that same material that we've sequestered into the water or held in the water, it will cause the scale to precipitate as calcium phosphate or magnesium phosphate rather than the carbonate versions of those salts. And what this does is it creates a soft, mushy scale that is very easy to remove, and hopefully it being flushed out with the dump cycle on ice machines or the blowdown cycle on combi equipment or through evening cleaning with coffee and espresso. But at the rates at which we feed for food service applications in our cartridges are mainly going to beverages and things like that, we do not feed phosphate at a level high enough to prevent corrosion in these applications. We feed typically less than 10 parts per million, more in the 5 ppm range of phosphate with our filters, and you have to feed over 10 parts per million to control corrosion. We do that in ware washing with the HTS11, where we feed much higher rates of phosphate simply because we're using it to protect a dishwasher, not add it to a beverage or a product. So what happens before and after phosphate with the water? Nothing really measurable is happening. What we're doing is just interfering with the scale buildup process by substituting phosphate instead of carbonate, and this is a soft, mushy scale that breaks up easily. Phosphates are denoted on our filter systems on the cartridges by a -S. If you see a filter with -S, that means scale control. We have the 7F standard and the 7FC-S. This is signifies scale control or phosphate. In our combination systems, the high-flow CSRs, you have 2 outlets on these systems, one for beverage quality going to fountain beverage, and then you have a scale stick feeder, the SRX feeder, that is plumbed to your ice, coffee, tea, and espresso applications, feeding phosphate downstream to those. Now, our filter systems are designed with a particular path in mind, and what we've done is we follow a series, then parallel flow through our filtration systems. What we mean by that is all the water is going to go through this pre-filter in one line. So the water enters here. Every drop of water is filtered by this filter, removing the debris. And then that water travels into a head. And these are a parallel design so that the water is split evenly over these 2 cartridges. So what we're able to do is double the flow rate versus a single cartridge and have that flow be balanced so that neither one of these filters will plug up before another. If this was all series flow, it would go in one filter, down into this filter, back up and out this filter. Well, this first carbon filter would be exhausted and plugged up far sooner than this one, basically rendering this filter useless. So with that parallel design, you have a series flow through the first filter that collects all the large particulate debris, and then that flow is split over whether it's 2, 3, or 4 filters in a balanced flow to increase flow rates in multiple and capacities of multiples of the first filter, and then out through a fountain beverage dispense point or drinking water dispense point and a dispense point for adding phosphate for scale protection for coffee, tea, espresso, and ice. And if you notice, these gallon per minute flow rates are just multiple of the first single 1.67 GPM cartridge, so that we're able to scale up flow rate based on that parallel flow path to the number of cartridges we can put in a manifold.